Its superpower would be that it's a very small sensor with the power of a much greater sensor. Super uncooled. My name is Philip Ely. I'm the Senior Director of Engineering at Leonardo DRS in Cypress, California. I'm the Principal Investigator on the multi-band uncooled radiometer imager, MURI. MURI was launched by the SpaceX Transporter-6 on Tuesday, January 3rd, 2023, as one of several hosted payloads within Loft Orbital's YAM-5 washing machine-sized satellite. MURI is a smaller version on the TIRS instrument. The TIRS is more like a telephone booth size instrument, and ours is on the order of roughly a cubic foot, 35 centimeters by 30 by 30 centimeters. So we have a much smaller system. We don't have a large cryocooler that takes up size, weight, and power, which significantly grow the instrument. Land temperature and water temperature are very important for scientists to be able to understand water monitoring, how full lakes are, for crop monitoring and other land imaging, such as fire monitoring. There's also interest in infrared for volcanic monitoring. In order to achieve radiometric accuracy on the order of 1%, state-of-the-art for radiometers, we use three techniques. The T-comp algorithm will adjust for global changes in temperature. The telescope temperature and the focal plane temperature are changing together. In addition, we have heater controllers to control the temperature throughout the orbit. And then thirdly, we use a calibration paddle that flips in front of the telescope, and then DC restores the sensor output. We take out any radiometric error that may have crept in and that the temperature may have shifted from when we did our original calibration. MURI can't afford image motion because you're flying over the Earth from low Earth orbit at 7 kilometers a second. The imagery from the scene is moving across the focal plane. So what we came up with was a technique to backscan the focal plane in a way to match orbital velocity, the piezo stage, that moves the focal plane very small distance on the order of a millimeter. It stares at the scene, it moves ahead about a millimeter, and then snaps back and does that again and again. And so what you have is a step-stair system. And then we also do what's called frame stacking, superimposing those frames in order to create an image that's looked 10 times as long. I think one of the exciting things about working an ESTO program is that you get to see the results in a pretty short time scale. But to get up into space in less than 2 years, that's really an accomplishment. That's something I'm really proud of. We came up with the idea, we found the right sort of application. MURI, the multi-band uncooled radiometer imager, super uncooled.